I'll be addressing a subject called sustainable waterproof for net zero. See, let's now just get, let's look at what net zero buildings are. Net zero buildings, for net zero buildings, the waterproof has to be executed right the first time. No? First is, in a net zero building, it is all about minimizing energy consumption buildings. So when water intrusion happens, it compromises the insulation, it compromises the waterproofing quality, and it allows to increase the heat transfer through roofs and walls. Waterproofing also reduces the moisture buildup and lowers the need for dehumidification and lowers the overall load on HVAC systems. So thereby it saves energy. Now, the second aspect is preventing structural damage and mold growth. So water moisture or moisture causes significant damage to interiors, building interiors like wood, dry walls, concrete, and what then that happens, steel corrodes, and all of us know what happens to corroded structures. Waterproofing provides a protection from attack and deterioration. So it protects building materials that are used in construction. It also, moisture promotes growth on walls. Effective waterproofing will, help remove all these issues, and it controls mold growth. It also supports renewable energy systems. Waterproofing contributes to a more airtight and insulated building envelope, most essential to reduce the load on on-site renewable energy systems. It enhances the building envelope efficiency. In net zero buildings, photovoltaic cells are generally used. So when you execute a waterproofing of a roof or a wall properly, and integrate the waterproofing along with the solar panels and other non-conventional energy systems installed on buildings, it provides a long life and optimal performance of the solar panels. Okay, so now here you have a picture of a typical solar panel here. You can see the building, which looks like glass. In fact, that is a solar panel. Instead of a concrete wall, the entire building has been installed with a solar panel, which looks like a facade of a building. So the installation of these building integrated photovoltaics replace conventional building elements in the parts of the building envelope and in facades. So building envelope means, suppose you assume that a building is about is like a rectanguloid, a long rectanguloid. The entire area, surface area of the building on all 6 sides is enveloped. So that is called the building envelope. So we have to do whatever it takes to seal the building envelope. So existing buildings also can be retrofitted if we want to make them net zero. The advantage of the integrated photovoltaics over more common non-integrated systems is that the initial cost can be offset by the cost of regular building materials. So that means if you are replacing a panel of solar panels with a regular wall, the cost of the building wall is saved and it is replaced by the cell. And also the cells, they give power. Now, waterproofing for net zero buildings is not a separate subject. In fact, it has nothing to do with net zero. Net zero building is something that whatever energy it's consumed, it is replenished or equaled by the non-conventional energy sources it takes. So if you want these net zero buildings to perform, waterproofing has to work properly. While, we have many colleagues today speaking today on waterproofing, I'll just focus on what are the important things. First of all, for net zero buildings, choosing a very, very high quality durable waterproofing system is extremely important. Otherwise, the functionality of a net zero building comes down. So waterproofing systems that can stand with weathering, UV exposure, environmental attack must be selected for long-term performance. If you take insulation and building in net zero buildings along with waterproofing, which is mandatory, both the waterproofing and insulation systems must be complementary and compatible with each other. So which ensures that they give a long-term performance. Okay, so very important in waterproofing in net zero, like any other high-end building, is about proper detailing. Detailing means all the corners, the edges, the transition planes, they all must be properly sealed. Very carefully, the architect and the consultants must be looking at their uh, designs, drawings, and seeing that none of the areas which are loosely detailed, they should exist. They must completely detail out on the on every section, corners in the buildings. So when it comes to insulation and waterproofing, as I was saying, they must be compatible. There is something called as a 90 by 1 rule. 90 by 1 rule is where sealing off effectively, where 90% of the water intrusion occurs within 1% of the total building's exterior surface area. Now, just look at the systems. For example, this is a basement picture, and you can see a basement being applied there. And the blue part in the picture is the HDPE membrane with laps and seams. This is the best system for rafts in construction. In India, if you look at it, HDPE has gained prominence worldwide. It is done everywhere in the world. Yeah. There are other kinds of membranes like HDPE membranes also, which I can explain. Say, for example, in unconfined walls, sorry for the spelling mistake, one should always choose a hybrid polyurea, because the hybrid polyurea the pure polyurea is not very flexible. It's used more for food grade applications and all that. But a proper hybrid polyurea, which is pre-applied, it is the best chemistry, blending the polyurethane and polyurea. Better elongation and tensile properties over pure polyurea. Although good polyurea, but it's less flexible. That's why hybrid polyureas are opted for waterproofing. If you look at the confined retaining walls, it is always, that means a blind side, or where you cannot apply from the other side. It's always best to go in for membranes which are self-healing, self-curing, and self-sealing, which are airtight barriers. They have got layers, as you can see here on the right side. There are several layers. There are some non-woven fabrics that promote adhesion, mechanical adhesion to concrete. So this kind of a membrane is a high-end membrane. It is expensive, but if you want a net zero building to perform 100%, you need such systems. The cost initially are high, but to maintain a net zero building, if you install the best systems in waterproofing, the maintenance comes down to zero over a gradual period, say of 5 years, 10 years. There is absolutely no maintenance. So that is the principle in which we are trying to operate. Now, in the walls, there is walling and insulation. Now, insulation, if you look at it, you just see the picture, there are several layers. So number one is the concrete, the substrate, concrete or plaster. Concrete is preferable, but you also have plasters in cases, some portions of the walls. Then you have an adhesive mortar. Then there is an insulation mineral wool. Why is mineral wool applied instead of XPS boards? It's because they are fire resistant. Then the base coats. Then there is a mesh, which is about minimum, that is 160 GSM, a woven glass fiber, which is again fire retardant. Then there's a top coat for that. Then there is a primer for the textured paint coating. And then there's a waterproofing textured coating, which is about 1.5 to 2 mm thick in color, of choice colors. So this is an excellent walling insulation, which is available in India today. Something called a sealing of transition. That means whenever a concrete and a glass plane intersect, or concrete and wood intersect, wood and metal intersect, or whatever, very important is to seal those transitions. So that's a question of detailing. So very important part in detail. So these detailing materials are extremely important. They are not cheap, but they are once applied, they permanently seal all your transitions. They're suitable for all kinds of roof detailing and repairs. Virtually all kind of roof materials can be applied. These materials, this liquid applied membrane, this transition liquid applied membranes adhere to any kind of a surface. They generally are fully reinforced, although they are liquid applied. They can be applied at low temperatures. They are rapid curing, and they are allowed to design to allow use on many on vertical surfaces also. They can be applied on vertical transition planes. Not but last
Okay.
the wet areas, bathroom, very high quality materials. Then last but not the least is the building envelope sealants, which there are variety of sealants, and always use the best quality of sealants and the right sealant for the right purpose so that your building envelope is completely sealed. Yeah. So with this, ladies and gentlemen, I end my presentation. Thank you very much.